All right, so welcome everybody. We are excited to continue our new FAFP webinar series this afternoon and glad for the excellent turnout. We certainly like to thank all the members and sponsors for your ongoing support of FAFP. Just a few housekeeping items before we get started. Please keep your video and audio off throughout the duration of today's program. We're going to ask the students to answer questions from the audience at the end of each of their presentations. So we have a team of volunteers who will be monitoring the chat box and facilitating your questions with the students. So if you have any questions as you go along, please type those directly into the chat box. We will also be recording these proceedings and then posting them on the website at fafp.net. Many of you know that we are supposed to have our annual education conference in St. Augustine a few weeks ago, where we would have celebrated our 75th anniversary. So fortunately, many of the speakers have agreed to participate in this webinar series. One of the elements of the AAC is the student presentations. Students from all Florida universities are invited to present their work at the AAC. Which is beneficial because they're the ones that are actually doing some of this cutting edge research that you all hopefully will benefit from. And upon graduation, they'll become the next generation of food safety professionals. So they're going to be looking for jobs. So we'd like to create an opportunity to both share the research and create some networking opportunities for the students so that, you know, you might be able to find a new employee. And so with that, we'll start with our first presenter. This is Gabrielle Allen. She is an undergraduate at the University of Florida studying in animal science. And the title of her presentation is Control of E. coli 0157H7 and Salmonella during production of Ethiopian quanta. So Gabby, if you're ready to go.
Hello, everybody. My name is Gabby, and in my undergraduate research project, I investigated the risk associated with the production process of a traditional Ethiopian beef product known as quanta. So a little background on Ethiopia. Ethiopia is home to one of Africa's fastest growing populations, and they also have one of the largest livestock inventory in Africa. Despite their fast growing population, they do have a 37% incident rate of stunting in children. 4 out of 10 children under the age of 5 are stunted, and diarrheal diseases is the major cause of death and the leading cause of childhood mortality. Even with a large livestock inventory that Ethiopia has, their per capita consumption of animal source foods is very low. There are many factors affecting food safety and low consumption of animal source foods. One of them is that they have no means of food safety training, so they have knowledge gaps in hygienic handling and sanitation. Since Ethiopia is on the equator, they have no cultural memory that cold means preservation since they've never seen snow. Therefore, they have a preference for raw meat, and in combination with their unreliable power grid, they have few preservation methods using refrigeration. They have minimal commercial meat processing. So instead of processing the meat for commercial, they just, in the butcher shops, they used the meat products and they just cut it up and sell it like that as a whole cut, and then the Ethiopians will take it home and process it even further. 2/3 of the Ethiopian population is Orthodox Christian. Therefore, they have a lot of religious fasting. More than 200 days out of the year involves fasting. Children under the age of 7 and pregnant women are exempt for this. However, even butcher shop owners are Orthodox Christian, so that slows the production of animal products. Therefore, when access is limited and the general nutrition is poor, the safety of food is critical. There are other limitations like the internet restrictions. The government restricts internet access, therefore they have no way to do any kind of food safety training. They also have minimal understanding of foodborne illnesses and how they are caused and the preventions to prevent these foodborne illnesses. And they also have an inefficient livestock production practices and animal welfare. Ethiopians have an incentive for speed. Therefore, they want to slaughter and process the animal for consumption as fast as they can. Therefore, my objectives and goals for this research project was just to simulate the quantum reduction and then assess the risks associated with Salmonella and E. coli, and then improve safety and availability of animal source foods in Ethiopia. So a little background on Quanta and what Quanta is. Quanta is one of the few preserved meat products that is made exclusively in the homes of Ethiopians. It is very labor intensive. A visiting Ethiopian scholar came to the University of Florida and taught me how to properly cut an average piece of meat into an elongated rope of meat, as shown in the picture. Basically, a chunk of meat is cut at an angle in basically triangles to form those elongated pieces of ropes. Quanta is consumed as is, so it can be consumed raw or it's incorporated into soups and stews. There is a product that is very similar to Quanta that is starting to emerge in the US, and it's called biltong. Biltong is a South African ready-to-eat salted and dried meat product. It was used as a survival technique, and then it was wrapped up in cloth and used during the winter time. It is dried out in the sun for 2 weeks, and it's cut into tongues or sticks and seasoned. The only difference between biltong and Quanta is that biltong is marinated. They use vinegar, whereas Quanta, there's no vinegar involved. There's currently produced using several recipes and processed to accommodate demand. So it is produced on a small and large scale, and it has gained popularity in international markets, and it is an emerging product within the US in the last few years. So in order to accurately mimic the production of Ethiopian Quanta, the Quanta was cut from a top round and then into elongated thin lumps of meat. And chambers were created to control the pathogen load and introduce an airflow that they would be receiving in the kitchens of these Ethiopian houses where Quanta is made. Quanta is hung on metal rails in Ethiopian kitchens, and that's where they stay to dry for 7 days. So I cut the Quanta and portioned it into about 20-gram increments. They were seasoned with a traditional Berberi spice that was from Ethiopia, along with salt, pepper, and vegetable oil. They were then inoculated with a cocktail culture of Salmonella and E. coli with 5 serotypes of Salmonella and 3 serotypes of E. coli 0157H7. There were 2 ventilation rates that were used for the 2 chambers. The low one had 2,600 exchanges per hour, and it displayed a gentle airflow, while the 3,700 exchanges per hour had a more constant airflow. The temperatures of these 2 chambers were at 22.2 degrees Celsius, which is about 71.2 degrees Fahrenheit, with a relative humidity between 60.8 and 66.9. The Quanta was placed in these chambers, and they were allowed to dry for 7 days, and then they were pulled and enumerated on days 0, 1, 4, and 7. And when they were pulled for enumeration, the weight of the Quanta as well as their water activity was accounted for, and the experiment was repeated twice. So the 6 strips on each day of 0, 1, 4, and 7 were pulled from the chamber. They were weighed and then placed in stomacher bags that contained 180 milliliters of 0.1 sterile peptone water, and they were then homogenized in the stomachers. The dilutions were mixed with TSA, which is tryptic soy agar, and then overlaid on the selective media for Salmonella and E. coli. The selected plates were XLT and then McConkey. And an additive was actually added to the McConkey plates to better recognize E. coli 0157H7. And then the plates were manually counted after 18 to 24 hours at an incubation of 35 to 37 degrees Celsius. So despite the two ventilation rates, there was not a significant difference in their drying weight. But however, on day 1 at a higher ventilation rate for water activity, it decreased faster but resolved by day 7. So during the drying process, there was a log reduction of salmonella, which was 1.7. And then for E. coli, there was a 3.5 log reduction in the drying process. So Quanta lost 65.9% of its weight by day 7 when compared to day 0, whereas on day 1, it was at 53.4% of its weight, and then on day 4, it was at 65.4% of its weight. The water activity did decrease faster at a higher ventilation rate on day 1, but it resolved at a similar water activity by day 7. The drying process did result in a 3.5 log reduction for E. coli, and then a 1.7 log reduction in salmonella by day 7. So from this research project, we found that air drying without any form of heat treatment does significantly reduce pathogen load in Quanta, although there is still improvement needed. And additional processing intervention should be utilized to further mitigate the risk. So my next steps in this research project would to be test variables that could reduce the pathogen load to a safer consumption level. And when I test these variables, I will be keeping in mind that there'll be variables that can be culturally accepted by Ethiopians, since the Quanta making process is an old grandmother recipe. So they follow that and they don't really go about changing it. I will continue challenging studies to validate the control of salmonella and E. coli, and then I'll also investigate safety risk of the processing interventions used in Ethiopia. Is there any questions?
Thank you, that was really interesting. We do have questions. The first one is, did you do shelf life for months?
No, since Quanta is a dried product, and like I said, it is it's their grandmother's old recipe. Therefore, the way they go about it is they're really precise on the way that they make it and the way that they incorporate the spices and everything. Therefore, I was just mimicking their Quanta production just to see if there is any risk associated with the safety of the Quanta.
Great. And the other question is, do you think American customers would be interested in a product like Quanta?
I do think that people in the United States will be interested in a product like Quanta just because they're already interested in biltong, which is a very similar product to Quanta, except that biltong is marinated. The only thing with biltong is that a lot of people wish it was a little bit tender, I guess chewier instead of as hard. And the thing with Quanta is that it's a very hard beef product. Ethiopians actually enjoy the fact that they can sit there and chew on it for a while, especially since they already consume raw meat. So.
All right, and one more question. Can you explain how it's different from beef jerky?
Yes, so beef jerky is put into hydrators and is hydrated, whereas Quanta, it is laid out into these Ethiopian kitchens. So it is exposed to the air, and it's not in like a supervised environment like beef jerky is with the dehydrators. Quanta also uses an Ethiopian Burberry spice, whereas jerky uses American spices or whatever the Americans prefer.
Great. That's all the questions at this time.
Thank you.
All right. So our next speaker, Xingyi, if you'd like to share your screen. Our next speaker is Xingyi Jiang, who is from Florida State, working under the direction of Dr. Rao. Xingyi is actually a past recipient of the FAFP scholarship, and this is the third year that she's presented at this, so she's got to be getting close to being graduated, right?
Yeah, hopefully
right.
Next summer.
So if you're looking for a good employee, Xingyi might be a good option for you. So Xingyi, the floor is yours.
Okay, thank you for the introduction. Hello everyone, my name is Xingyi. I'm currently in the third year in Nutrition and Food Science at Florida State University, and hopefully I'll be done for the next summer. Today, my presentation topic is monoclonal antibody-based sandwich enzyme-linked immunosorbent assay for porcine hemoglobin quantification. So just a brief introduction of the background. The sick pigs are inevitable during pig farming. In order to reduce the economic loss, the pig farmers usually try to find ways to resell those kind of pork meat on the market. As you can see in this comic over here, which basically the diseased pork are mislabeled as fresh pork to enter the food chain. So this food safety concern is usually happening in the developing countries. For example, in 2012, among more than 20,000 cases of food safety concerns happened in China, around 27% was caused by the circulation of those kind of diseased pork on the market. The major difference between the diseased pork and the fresh pork is the hemoglobin concentration. This is because if the pigs are dead due to illness or other reasons before the slaughtering, the bleeding process cannot be performed, which will trap huge amount of hemoglobin, which is the major blood component in the muscles. This will tend to have a higher hemoglobin residual in the diseased pork and fresh pork. However, the hemoglobin is reported to be a promoter for lipid and protein oxidation, so the excessive amount of hemoglobin will decrease the product quality and reduce the storage stability of the meat products. On the other hand, because porcine hemoglobin is a byproduct after pig slaughtering, it is often used as a colorant to bring the bright and appealing red color to the foods. However, without proper labeling, the adulteration of porcine hemoglobin can cause the religious concerns for the religious people such as Muslims and Jews. Therefore, in order to solve these issues, the major objective of this study was to develop a sandwich enzyme-linked immunosorbent assay, ELISA for short, to quantify hemoglobin concentration in meat products. So as you can see in the bottom image over here, this is an illustration of the format for the sandwich ELISA, which basically we need to find a pair of two antibodies to be used as capture and detection agent. These two antibodies are required to bind to the same protein with different regions so that they can form the sandwich structure. So in this study, we have performed the antibody characterization using Western blot and ELISA. During the assay development, we have optimized the conditions, established the standard curve, and validate the assay according to the FDA's guidance. Moving to the results part, first of all, we have performed the SDS page to study the protein profile from the porcine whole blood, porcine blood plasma, and porcine blood cells. As you can see from figure 1, the hemoglobin is the major protein that can be found in the porcine blood cells. It is a tetrameric protein composed of 2 alpha and 2 beta subunits. Under reducing conditions, this hemoglobin can be dissociated into beta and alpha subunit. And by using a 20% SDS page, we can clearly see that there are 2 bands which are very close to each other and had a molecular weight that is slightly below 15 kilodalton. After that, before further performing the antibody selection, as I mentioned earlier, that the criteria for forming a sandwich ELISA is we can find a pair of antibody that binds to the same protein. Because under reducing conditions that hemoglobin can be dissociated into alpha and beta, we have to find 2 antibodies that can simultaneously bind to the beta or simultaneously bind to alpha. If one antibody binds to alpha and the other antibody binds to the beta subunit, they will not be able to form the sandwich structure. Therefore, we have performed the fluorescent Western blot by using one polyclonal antibody that is already known to be immunoreactive with the beta subunit. As you can see from figure 2A and B, as I highlighted in the red letter, this polyclonal antibody can react with one protein band from whole blood, blood cells, and hemoglobin. This is the beta subunit of porcine hemoglobin. By utilizing this polyclonal antibody, we have identified 2 monoclonal antibody 2B6 and 24C12. Based on figure 2A and B, we have observed the single band in the green channel. When we combine the image of red channel and green channel, we observe the generated yellowish band. This is because an overlapping of the red and green color will generate the yellowish color. This suggested that for these 2 MABs, both 2B6 and 24C12 are immunoreactive to the beta subunit of porcine hemoglobin. During further characterization, we used the chemiluminescent Western blot to study the selectivity of these 2 antibodies. From figure 3A, as you can see, antibody 2B6 can strongly react with hemoglobin from porcine whole blood. However, some weak cross-reactive bands can also be observed in the other tested animal blood, including beef, chicken, goat, horse, rabbit, sheep, and turkey. However, their band intensity was much weaker compared to the band intensity compared to the porcine whole blood. On the other hand, the other antibody 24C12, according from figure 3B, it showed an excellent selectivity that only immunoreactive protein bands can be observed in the porcine whole blood. By using these 2 antibodies as capture and detection antibody respectively, we have established a 4-parameter logistic model, and the equation was illustrated over here. This standard curve had a working range between 15.6 to 3,000 microgram per milliliter with an EC50 value around 110. By using this standard curve, we have interpolated the porcine hemoglobin residual concentration from 2 locations of pork, which are loin and shoulder. So as you can see in this image over here, the pork loin were indicated in region number 2, and the pork shoulder were indicated in region number 7. So based on this table, we can see that after normal slaughtering process, the interpolated porcine hemoglobin concentration in 1 gram of loin and shoulder is 0.4 and 1.1 milligram respectively. As you can see in the red box, the interpolated level for the hemoglobin residual concentration in the shoulder is slightly higher. This is because the hemoglobin concentration is highly dependent on the location of the meat. If this portion is frequently exercised, it's supposed to have a higher amount of hemoglobin residue. In order to simulate the insufficient bleeding, we have manipulated 1 milligram and 5 milligram of hemoglobin in the pork meat. As you can see, the interpolated level increased as the function of the adulteration level. Finally, we also want to test this availability to identify the adulterated hemoglobin in the non-pork samples. So we have chosen the turkey breast as our second model. Under normal situation, the turkey breast cannot be detected with any porcine hemoglobin residual. However, after adulteration, small and big amount of porcine hemoglobin as colorant, we have used the standard curve to interpolate the levels. Overall, this table suggested that the recovery rate is acceptable. So in conclusion, through this study, we have identified 2 MABs that can strongly react with the beta subunit of porcine hemoglobin. We use these 2 antibodies to establish a sandwich ELISA for porcine hemoglobin quantification. This assay was validated to have a good sensitivity, a wide working range, and high reproducibility. We feel that this assay have at least 2 applications. On the one hand, through this assay, it can indicate the bleeding efficiency of the pigs. If a much higher of porcine hemoglobin residual was detected, it may suggest that the bleeding process may not be performed successfully. On the other hand, this assay can be used to identify those misbranded or adulterated hemoglobin in the non-pork meat samples. Finally, we would like to acknowledge the funding support from Hebei Animal Disease Prevention and Control Center and also the United States Department of Agriculture. Also, I would like to thank the FAFP for giving me this opportunity as the presenter. And if you have interest in knowing more about this project, we have just published this manuscript on the FoodCat. Thank you.
That was excellent. Thank you so much. So we have several good questions. The first one, are there any direct food safety concerns associated with hemoglobin presence in pork meat? Or is it mostly a quality issue and an indicator of disease in the pig slaughtered?
That's a good question. I think the porcine hemoglobin in pork meat is just an indicator of the insufficient bleeding. It won't pose any direct food safety issues. The major thing is related to those religious people that they were not allowed to eat any blood-containing foods based on their laws.
Thank you. Why are animals poorly bled? Is it an economics problem? And in what countries is this disease most prevalent?
Okay, so it's usually the bleeding, if it's not performed successfully, is because the animals are dead before the bleeding process. So usually, as you know, during the pig farming, the pigs might get ill and they may be dead before the slaughtering. But if you just throw the pigs away or bury them, the farmers will lose a lot of money. So in developing countries, they usually try to find ways to resell those kind of meat. But because of the bleeding cannot be performed, they are just trapped in the muscle. But I don't think this will be an issue in the United States. It's more in the developing countries such as China and Vietnam.
Okay, thank you for explaining that. The next question is, are there regulations in place to prevent diseased animals from entering the food supply in China?
Yes. It's kind of like prohibited. So there's law clearly illustrated that you cannot resell those kind of pork on the market.
All right. And the next question, is there any cross-reactivity between hemoglobin and myoglobin? It may explain the differences between pork and chicken.
Okay, based on our Western blot, which is over here, we only observe one single band is porcine hemoglobin. We did not see the cross-reactive myoglobin band. So I don't think there will be a cross-reactivity.
All right, that's all the questions. Thank you so much.
Thank you.
All right, our last presenter is Jessica Brown. Jessica is working on her master's degree at the University of Florida in the Department of Animal Sciences. I think Jessica, her project, it looks like got put on hold because of COVID, so she's taken more of a broad approach to her presentation. So Jessica.
Yes. All right, there it goes. All right, hi everyone. Thank you for joining us today. As Dr. Scheffler said, my project did get kind of put on hold a couple months ago. So even though I'm about to resume that now, I'm focusing my presentation more on an overview of all the different facets that are kind of associated with this big project that's been going on for about 5 years now. So the overall goal of it is to improve the food safety of the Ethiopian meat supply chain. So without being too redundant, as we already heard a quick presentation on this at the beginning, I'm just going to go over some brief background on Ethiopia. So as we said, Ethiopia is home to the largest livestock inventory in Africa, and although that might not seem like a lot, it's actually the 10th largest in the world. So despite having this big livestock inventory, they still have one of the lowest per capita consumptions of red meat in Africa. There's a lot of factors that play into why their consumption of meat is low. One of them may be the high domestic prices relative to the income of the population. And another one is religious fasting. So as we said, a large portion of the population is Orthodox Christian, which means they fast for over 200 days out of the year. So with this religious fasting, even though some portions of the population are exempt, the religious fasting affects the abattoirs and butcher shops and kind of puts a hold on animal production during that time. So even if you are exempt from the fasting or you don't participate in the fasting, your access to meat is still incredibly limited during those times. So what this all sums up into malnutrition contributing to over 50% of infant and child mortality in Ethiopia. There you go. So as you'd imagine, the supply chain in Ethiopia is very different from the supply chain we have here in the US. Similarly, they start with the producers, and unlike the US, they have a lot of more small livestock producers. And in order for them to sell their livestock to the fattener, which is almost equivalent to our feedlot system, they have to sell their livestock through a broker, which the brokers actually have to be certified by the government to buy and sell livestock. So the producer loses a little bit of money there with the middleman, but they sell their livestock to the fatteners and they go through the feedlot process, and then the livestock are brought to the livestock market. And in the US, we generally sell our livestock based off of weights. In Ethiopia, it's all based on a visual assessment, and they barter for these animals at the livestock auction. So the butchers are actually the ones that purchase the livestock from the producers or the brokers, and they purchase it based off of a visual assessment, and then they pay a fee to the abattoirs to actually process that animal and deliver them the meat. So as you'd imagine, this system is really based off of speed. And so when we're focused so much on speed, we neglect some of those food safety problems, and that results in some pretty staggering numbers. So a lot of research has been done, some different studies have been conducted to qualitatively assess the pathogen burden on meat in Ethiopia. So what we found was that about 5% of carcasses swabbed were positive for E. coli 0157. About 35% of meat samples tested positive for salmonella, and about 9% of the meat samples tested positive for Campylobacter species. That includes jejuni and coli. All of these statistics really culminate in why diarrheal disease is the second leading cause of death in Ethiopia. So this project, like I said, I'm going to give a brief overview of it, but really it's separated into two main groups. So we've got our capacity building projects and our meat preservation projects. So the first capacity building project we did was the needs assessment, and then after that was followed with a training of trainers program that was conducted in Ethiopia. So meat preservation was the next big group, and with that we developed a restructured beef jerky product, as well as you heard in the first presentation, we assessed the risk of the quantum making process. And hopefully, if Corona lets us, we plan to travel to Ethiopia in this upcoming year to conduct an enumeration study to allow us to test the efficacy of the training of trainers program and kind of get a quantitative assessment on the microbial burden that the butchers and abattoirs are dealing with. So the first part of this project was a needs assessment. So this project came about because we house the International Innovation Lab, Livestock Innovation Lab here at the Animal Science Department. And they focus on trying to help developing countries help themselves. So they provide them with tools and training programs in order to allow them to improve their systems on their own. So they have 7 target countries, Ethiopia being one of them. And so in 2016, Dr. Scheffler and a group of professors were able to travel to Ethiopia and kind of determine what aspects of the production needed help and how could they do that. So the first thing that they needed to do was a needs assessment. The real objective of this was to identify the pathways to improve food safety. And as you can see with the table on the right side, these were some of the areas of interest and what kind of results we observed. So the first thing that stands out is the availability of refrigeration. So although a lot of places had refrigeration available, only about 50% of them used that refrigeration. That refrigeration was dedicated for meat. A lot of times, because this system is based on speed, once the animal is harvested, it gets to the butcher shop within about 12 hours, and then it's sold the next day. So what they do is they just hang it on a metal rack in the back of the butcher shop, and through the day they just cut meat off of it and sell it through a window. So they don't really refrigerate any of that meat, it's just left out. And then at the end of the day, if there's scraps left over, they cut those up and they put them in a bag, and that's when it might go into the refrigerator. So that contributes a lot to spoilage and the lack of availability of animal sourced foods throughout Ethiopia. Another big thing is that hand washing sinks, although they were available, is they are often shared between the butcher employee and the customers. There's often one hand washing sink available for both of them to use. And in one case, it was actually 2 blocks away was the nearest hand washing sink. Some other things to point out is in the US, we focus a lot on PPE. And in Ethiopia, frocks were really the most common form of PPE. Hairnets were often not used, and jewelry was often worn. And the last thing we saw a lot was that in the butcher shops, they often used wooden cutting boards and wooden utensils, and all of you are food safety professionals, and you know that it's the golden rule not to cut meat on a wooden cutting board. So that might contribute to that pathogen being transmitted from one day to the next day. So some of our key limitations that we highlighted from this needs assessment, the biggest one was really the educational gap in hygiene and food safety. And this is what we really tried to target with the training of the trainers program. There were some other limitations. Gabby talked a little bit about how the climate and the historical knowledge of preserving meat using colder temperatures, they really don't have that historical relevance. So, and they're in a warm and humid climate. So that can contribute to kind of that lack of preservation and a limitation for preserving meat. Religious fasting, we've already talked about, is a big limitation. Infrastructure and market structure contributes a lot to the need for speed and not as much focus on the food safety. They also are, it's very culturally relevant for them to consume raw meat, and that's a sense of pride in their culture. So that's not something we can walk in and tell them it's bad, you have to cook your food. So that just adds another level of risk to the consumption of meat. So once we conducted the needs assessment, we used those results to develop a training of trainers program. And a lot of this was done by the previous grad student, Taylor Langford, and she actually got to travel to Ethiopia with Dr. Scheffler to conduct a 4-day training program. So the goal of this training program was really to train people to go train other people. So it was a 4-day program. The first 2 days were classroom trainings. So they went through food safety, hygiene modules, and did reinforcement activities to kind of solidify those things that they were showing them in the lectures. One of the days they did field visits, and they would travel to abattoirs and butcher shops, and they would do group audits to assess where these facilities were lacking and suggest some short-term, long-term goals for the future to improve their food safety. And the last day is when they planned their training. So they discussed and presented some different training plans for those employees to use to go back and train other people at their respective locations. So a pre and post test was given before and after this training, and they actually demonstrated almost a 10% knowledge improvement. And so that showed us that the training was working. And since then, this training has been scaled up to around over 300 people thus far. So going past capacity building, transforming a little bit into the meat preservation portion, a little background on meat preservation. Drying meat is one of the oldest forms of preservation, and it's used by countries all around the world. Ethiopia is no exception. They have their traditional form of jerky called quanta, which Gabby talked about earlier, so I won't hash too much on it. But even in the States, jerky products have still been linked to several gastrointestinal outbreaks, oftenly associated with Salmonella and E. coli. So validation studies still do need to be conducted to make sure that this jerky drying process is sufficient to provide us that pathogen lethality that we're going for. The overall goal of meat preservation is that without it, the spoilage rate is a lot higher. So figuring out a way to preserve meat and kind of bridge that gap during the fasting periods in order for someone at home, if they're not participating at fasting, they can still have access to a high protein, safe product. So a little bit on this, not gonna hash too much, but quanta is that traditional Ethiopian beef jerky. It's one of their only forms of preserved meats that they really use. And it's often just done in the home. As Gabby said, it's kind of a mom and pop recipe. So it's very special to them, but it's not really commercially processed. It's a time-consuming process, and it's a difficult technique, and they're not doing it on a commercial scale. It's more of someone brings the meat home and does it in their kitchen themselves. So what she did with that was that she simulated the quanta production process to assess the ability to control those major pathogens that we're concerned about. So with that being said, quanta is not really commercialized. We wanted to try and develop a product that could be commercialized and still provide that safe, shelf-stable product for the Ethiopian consumer. So what we decided to do was develop a procedure for a restructured beef jerky product. That basically means that you take a chunk of meat and you grind it up and you restructure it back into strips, and then you put it into a home style dehydrator and allow it to get down to a certain level. We went under 0.7 water activity in order to achieve that shelf stability. We were really trying to target that 5 log reduction of Salmonella and E. coli, and we had to do this with the limited amount of equipment and ingredients that are available in Ethiopia in order to make it relevant and feasible for them to perform. So throughout this process, we evaluated different antimicrobial ingredients that could be added into the beef jerky formulation. And some of those included vinegar and raisins, and we're still exploring more, but that helped us achieve more of that log reduction. But once we did this, because this is a new product, we wanted to determine the acceptability from the Ethiopian consumer point of view to see if they would even eat this product or like this product, and if there was anything we could do to help that. So the first food additive that we used to put into the meat was apple cider vinegar. We were hoping to drop the pH and achieve a higher log reduction, and the opposite occurred. So we did preliminary studies in order to assess kind of what that effect of the vinegar would be on the restructuring of the product. So we did 8% vinegar and a couple different inclusion levels in between there, and then the control. What we found was that too much vinegar caused the product to fall apart, and it really didn't allow us to get that nice strip that we were going for. In addition to the lack of, or to the negative impacts on the end product quality, we also saw a negative impact on the log reduction of Salmonella. We actually had less of a log reduction with the vinegar versus without the vinegar. So after this trial, we kind of concluded that vinegar was probably not the most effective way to improve log reduction. The next ingredient we added in was pureed raisins. Antimicrobial effects of raisins have been researched in the past, and it blended in pretty well with our beef jerky product. So what we found from that is we added in 5, 10, and 15% raisins by weight of the jerky mixture. And we found that we actually achieved an extra log reduction with 15% raisins when we compared it to the control. And that's with our Salmonella enterica. All the formulations exceeded the 6 log reduction of E. coli ON57H7, and it actually maxed out our limit of detection. So this is probably a conservative assessment of the reduction levels. So once we determined that the inclusion of the 15% raisins helped us achieve that 5 log reduction that we were shooting for, we held a consumer taste panel with about 16 Ethiopian nationals to try and assess whether their palate was going to be, whether this was going to be acceptable for the Ethiopian palate. We did use a Burberry spice mixture that's traditional in Ethiopia to try and make this more of an Ethiopian style product. But we compared 0% raisins with 15% raisins and found that there was actually no significant difference in likability. They were both pretty acceptable. They did like the control just a little bit more, but they said that the inclusion of 15% raisins made the product just a little bit sweeter and that children might actually prefer it, which is a definite win if we can get children to eat more of this product. Another comment we got often was that they wanted more bite to it. They're used to really tough meat in Ethiopia, and so the fact that it was a restructured product and it crumbled a little bit more, they'd like it to be tougher. So to wrap all this up, the needs assessment was successful in identifying the areas along the supply chain that we could improve with little financial input. And the training of trainers program was successful in building that capacity of trainers, and hopefully we'll continue on to continue building that capacity and improving their knowledge of food safety. The inclusion of 15% raisins had a positive impact on the log reduction of Salmonella enterica, and all formulations exceeded that 6 log reduction of E. coli, including the control. So with those two together, we kind of deemed that this process was pretty safe, and so we were pretty happy with these results. As Gabby said, air drying without heat treatment did significantly reduce the pathogen loads, but improvement can still be made with different intervention steps in order to improve upon that log reduction and make it even safer. And even though this restructured product was designed for Ethiopia, it still is culturally relevant, this process is still applicable to the US consumer, and it can be applied in more of a low-cost production scenario. All right, and some of our next steps with this project is hopefully within the next year, I will be able to travel to Ethiopia and conduct an on-site enumeration study in order to assess the quantitative microbial load of pathogens and bacteria in general, and see how that changes from beginning of production to end of production in a day. It'll also allow us to validate or evaluate the efficacy of that training of trainers program. Some next steps with the restructured beef jerky will be to do additional challenge studies and add in Campylobacter jejuni, as we saw that there is a significant prevalence of Campylobacter in Ethiopia on their meat products. We'd also like to add in acid-intolerant Salmonella enterica. This is because when Salmonella get that acid tolerance, they also get a co-tolerance for thermal temperatures. So when they're more thermotolerant, we want to make sure that our process kind of knocks them out and causes that pathogen lethality, regardless of how tolerant they are. One of the big things I want to look at is evaluating the pathogen reduction during the drying process. So when we did this original project, we evaluated the pathogen load before drying and after drying. However, with Ethiopia's inconsistent power grid, we really want to find out how long it takes us to achieve that pathogen lethality, to know that if the power goes out, you need this much time in order to make that product safer for consumption. In addition to the restructured products, we're going to explore some additional formulations in order to accommodate for a wide variety of consumer and different consumer tastes. We'd also like to add in more antimicrobial intervention ingredients. That way we can make more formulations on what is available to the consumers or producers and give them more options. I'd like to say thank you to the Feed the Futures Lab, the translator that helps when we go to Ethiopia, and Dr. Beslam for setting up the consumer taste panel, and a large group of people from the Meat Science Lab, especially Taylor Lankford, who was the previous grad student on this project and did a lot of this work that passed on to me. And thank you to our funding came from the Bill and Melinda Gates Foundation and the Department for International Development. If there's any questions.
All right, great job, Jessica. So there are a couple questions. Are raisins readily available and economically acceptable in Ethiopia?
So when we started this project, we were looking at different antimicrobial intervention ingredients that were available in Ethiopia. So raisins were found to be readily available. As far as acceptability goes, when we did the consumer taste panel, they did notice that it was a little bit sweeter. However, it was still acceptable in their opinion, and they thought it would appeal more to a child's palate, that they would like the added sweetness in the beef jerky.
Great. And why is a 6 log the target log reduction?
So generally in the US, the USDA sets a standard that we want to achieve a 5 log reduction of Salmonella and generally a 6 log reduction of E. coli. And that's more of not necessarily an arbitrary number because it is researched and proven, but that's kind of the level they set that they're comfortable with that being considered a safe product. So although Ethiopia doesn't have those regulations in place that tell us we have to achieve a certain log reduction, we want to try and get as much of a reduction as we possibly can, especially since we don't necessarily know the concentration of the pathogen load in Ethiopia. So we really try to shoot for that 5 log reduction in order to make it a safer product.
All right, and that's all the questions.